Hello, hello everyone. So back to my math videos. Today's is still math 24, calculus 1. And today's topic, it is the last differentiation technique is logarithm differentiation, which is section 3.6. It's a logarithm differentiation. So in previously we discussed implicit differentiation, which the differentiation a multivariable function, but it's not partial derivative. That is what we learned in method 26. So in these cases, what is logarithm differentiation is if you have a function and that doesn't look like a function have a power of another function. For example, if you have is y equals to f of x equal to f power to the g of x. So it's like y equals to f of x power to the g of x. Then what you would do? In this case, the chain rule doesn't work. So you need to write them to like natural log of y. So how to find y prime or dy dx? So this technique just allow you just to write them into natural log of y equals 2. So in this, and reduce like a natural log of y equal to the gx times natural log of f of x. And now we just take the derivative of this. It's like 1 over y dy dx and equals to implicit and chain rule. So this is a chain rule and product rule. So by chain rule, we get like this, and was and product rule, just basically all the rules we can use. And then we want this dy dx. So we multiply y on two sides. plus g prime of x, like natural log of f of x. And the y, it is fx to the dx. That is the dy dx you want. It's going to be f of x to power of g of x. Then just multiply this big chunk of function, gx times f prime of x over f of x. And then plus g prime of x, the natural log of f of x. Okay, this is like how to do logarithm differentiation. And I've introduced another kind of a derivative rules. Just the more derivative rules. So if we have more derivative rules, we just have to I just look for it. Sorry, I was replying a message. Now we just gonna have some like natural log of x. We just derivative root number one is the dx of natural log of x equals to 1 over x. If this inside of it's not an x, it needs to chain rule. And then number two, it is a constant to the x. It's like the dx to like the ax. It's gonna be like ax and the natural log of a. Make sure a is not a 0. And then it's gonna be like log. If it's the dx of like the log to the power of a, then x. Then this is logarithm, and just gonna be 1 over x times natural log of a. And then number 4, most importantly, introduce like another is like if it's like a power rule, but it's like a higher power. So we just do like if it's the dx of fx to the n is the chain rule. If you can get them, it's like it's gonna be n f of x poverty to n minus 1 multiplied by f prime of x. So let's do some example because this is more computational unit, like the part of chapter 3. So let's try example 1. How this like talking cameras like this thing, So find f prime of x if f of x, it can be like the natural log of x cubic minus x squared. Okay, so this is like basically not same as f prime of x. Is so the rule I need to use is the chain rule. So when we do the chain rule, we just set f prime of x and equal to u equals to x cubic minus x squared, and f prime x is going to be the dx of x cubic minus x squared, and then du of natural log of u. And then you just do all the derivative things here, just going to be 3x squared minus 2x. I'm going to be 1 over u, and u is going to be x squared minus x cubic minus x squared. So put together that f prime of x, it is going to be 3x squared minus 2x over x cubic minus x squared. So this is f prime of x. Number 2. It's going to be find the derivative so if y equals 2 x power to the sine of x. Okay, this case is that you can't do the chain rule, right? Because it's kind of a complex function, and so we use the Locative differentiation. We rewrite them as like the natural log of y is equal to gx. It is the sine of x. The f prime of x over is going to be 1 over x, and then plus cosine of x, it is g prime of x, just natural log of x. And then we take the derivative of natural log of y, so we get this 1 over y dy dx is equal to this, as we just combine them into the same step. We just have this, I already expand this chain rule already, so I'm so sorry about it. So the previous step, I need to do like a revision here. This is not this. I apologize for the mistake. Unexpected. Then multiply by y, so get the dy dx. It is here. was just gonna be the cosine of x and have natural log of x. And the y just x times the power of this to this sine of x. Just and you can see it's like dy dx. It is x power to the sine of x, then gonna be sine of x over x plus cosine of x times natural log of x. That is the answer we want. Let's do another example, number 3. Find the derivative if f of x, it is going to be 15 over x plus natural log of x plus 1, then minus e to the 5x. What rules to use are going to be logarithm, chain, and logarithm. Just apply chain rule, and chain rule is going to be 1 over x plus 1 minus 5e 5x. This is the derivative. Let's find out example number 4. So find O point on the curve severe the tangent line is horizontal. So it is gonna be g of x equal to natural log of 3x squared minus 6x. If you see a function that is have natural log of inside the function and horizontal tangent line, so what you need to find it is g prime of x and so when g prime of x equal to a 0. So this is what you need to find for logarithm differentiation, for example, 4. Now is g prime x by the chain rule. And we do is going to be the dx of 3x squared minus 6x, and then du of natural log of u, and g prime of x, it's just gonna be 6x minus 6, the time gonna be 1 over u. So g g prime of x, it is 6x minus 6, and then 3x squared minus 6x. So if for j is equal to a 0, set the denominator as a 0, set the numerator as a 0. So at x equal to 1, the tangent line is horizontal. Let's try another example. Example number 5. Find the derivative so we have it's going to be y equals 2 square root of x. How over to the square root of x? Wow, this is going to be a complicated function, but don't feel afraid. We're just gonna solve because like their x probably the 1/2. So what do we do? Just do logarithm differentiation. So we get this natural log of the gx is gonna be x to the 1/2. Hence like natural log of x to the 1/2. And then differentiating is going to be dy dx. Do this chain rule here, and it's going to be like a 1/2. It's going to be actually the 1/2 times the 1 over x to the 1/2, but it's kind of a 1/2 over x to like a negative 1/2. Plus 1/2 of x to like a negative 1/2, the natural log of x to the 1/2. And then times the y, it is going to be dy dx times to the y, and then to the whole thing. Plus 1/2 over x to the negative 1/2, gonna be natural log of x into 1/2. Now I have this and just to multiply, and it just said dy dx, it is it's gonna be like the square root of x times square root of x, then this. That is all the logarithm differentiation. Okay, I think 5 examples kind of enough. And do you want to do more? But I can. So this is a kind of an easier unit, but I will try one more example so you can see what is logarithm differentiation look like. So example 6. So find the derivative we have is f of x equals 2 e sec x squared minus 8x. They have is this chunk is going to be 6x to the fifth and minus 12x to the fourth, then to the cubic. Well, now you just use the power rule, chain rule, and the product rule. Those are the main methods for this question. And it's going to be e to the sec x squared minus 8x. The dx of this chunk and it's going to be this chunk derivative of this. And then I just do the prime because it's derivative. And e to the 6x squared minus 8x derivative and times this chunk. And then add this chunk. Take the derivative is going to be 3 6 to the fifth minus 12x to the fourth squared. Just take the derivative going to be 30x to the fourth minus 40x to the cubic. This is f prime of x. Okay, that is all for logarithm differentiation. And next video going to be section 3.9, which is the hard word problem. It's called related rate. Thank you so much and have a great day.